Hello.
Hi, we can hear you.
Oh, okay. Thank you for that, Velma. Good evening. Um, I hope everyone is doing well. I'm also doing well. I'm trying to share my screen. Can you guys see my screen?
Yes.
Okay, perfect. Um, okay, so yesterday we had a session. Uh, Basically, we were discussing logic, conditional statements, and functions. And then we were supposed to also discuss on version controls, but of course, we started the meeting a little bit late, so we couldn't handle everything. So it was agreed that today, instead of the code challenge alone, we are going to handle version control. And then after that, somebody else who is Ebenezer is going to take us through the code challenge. So yesterday it was Naomi who took us through yesterday's session. She did a good job trying to explain to us everything about logic, conditional statements, and functions. Um, we managed to post that on YouTube, so you guys can also check the link out. So basically today I'm supposed to take us through version control, and then another
Recording
person
in progress.
is going to take us through the code challenge. So for some reason, I'm a bit lazy. I didn't prepare the notes the way Naomi did it yesterday. It was really nice. So um, what we're going to do is I'm just basically going to write, we can say maybe summary notes as we go through the content. All right, so before we start this session, um, probably I might read these names wrongly based on my accent and where I come from. But there are two people I want you guys to, what is his name? Linus Torvalds. And then you also have these two people. They are prominent people in, well, we are doing data science, and data science incorporates a little bit of software engineering, or we can say software development, because we're basically learning programming languages. So in the field of computing, of course, we have very many people who have contributed into the field of computing, but based on what we are learning right now, if you're not familiar with these names, at least you should be. You can Google out and read more on these two names. The first one is this guy called, I don't know if this is the best way to pronounce it, but I pronounce it as Linus Torvalds, right? And then the second person, well, the first person here, this is the guy who created an operating system called Linux. We have three operating systems, major computer operating systems. That is Windows, which is the most common one. We have Linux, and then we have Mac OS. So this guy created the Linux uh, kernel, not like the entire operating system. He created the kernel. We are going to talk about what a kernel is. And then he also created what we're going to learn in this session, which is Git. Some people pronounce it as Git, but may I pronounce it as Git. So again, that also depends where you come from and whoever your teacher of English was. And then the second person here, um, the way I pronounce this name is Guido van Rossum. And I'm not sure if this is the correct spelling for that last part of the name, but this is the guy who created the language that is commonly used today, which is Python. Um, Good thing about the projects that these two people have worked on is that they are open source projects. So when we say something is open source, it means the source code can be accessed by anybody. So basically what they did is they created we can say they created the first versions of these things we are using, and then they released it to the public, and then other software developers can now contribute to whatever they have done, right? So that is what open source basically means. For Windows, I don't know if Windows is open source because I've never seen the source code for Windows. But for Linux, for Git, for Python, it's out there. You can easily get it. You can also contribute by, writing few lines of code and also, uh, um, or you can contribute by just writing documentation or whatever it is. So that's that. That's a small introduction on these two prominent names in the field of computing. And I had to bring this up because basically what you're learning here is based on whatever they created. Okay. So today you're supposed to learn about version control, right? But before we learn about version control, there are few things we need to understand, right? So number one thing I want us to understand CLI and then GUI or GUI. Okay. Once we have understanding of these, then the second thing we're going to talk about which is Git, uh, GitHub is going to be easy for you to understand. Okay. So let's start with the first one, which is the CLI. So CLI stands for command line interface. Okay. So when you say command line interface, it's basically you can say it's a text-based environment. Environments. Okay, I've started butchering spellings quite early, but okay. It's a text-based environment where you can type commands, where you type commands, uh, and then these commands are able to interact with your computer. Okay, so you type commands to interact with the computer. Okay, GUI stands for graphical user interface. So GUI is the most common one we use, right? When you go to your Windows computer, sorry, okay. When you go to your Windows computer and then you go to the File Explorer, this is basically the GUI. You're accessing your computer uh, through the graphical user interface. There are buttons, there are icons you can click. So you can click on pictures, you can click on documents, you can click on this PC and all that. So this is the graphical user interface, whatever you normally use, right? When you come to this side and you click on Brave browser here or Ice Cream or whatever, you're basically accessing your computer using the graphical user interface, right? But then there's another way of accessing computer or interacting with your computer, which is through the commands. through text-based commands, right? It's the most powerful one. So that is why not everybody is allowed to use it. And for you to be able to interact with your computer through the CLI, you need to learn some basic commands, right? When I say it's the most powerful, it means there are things you can do through the CLI that you cannot do through the graphical user interface, right? Now, um, we're going to learn a bit of these commands on Windows because this is the most common operating system, okay, that everybody uses. At least we can say like 90% or 95% of the entire world or computers in the world, they run on Windows operating system. So that is what we are going to use. We also have a few people who use Mac OS, and then we also have people who use Linux. Okay. Um, for people who use Mac OS and Linux, um, the commands they use are almost the same. They're similar because when these two operating systems were built, they are basically what we call the Unix. They're Unix-like operating systems, right? So their kernel is built somehow the same, but for Windows, it's a bit different, right? So we are going to focus more on Windows, okay? So now Windows has two main ways of interacting with the operating system through the CLI. So Windows has two types of CLI. Okay. So the first one is which is the most common one is the command prompt. The command prompt. So the command prompt is the classical terminal. We are going to understand what a terminal is in a few. And then we also have PowerShell. So PowerShell is a bit advanced compared to compared to command prompt. Okay, it's advanced in terms of when you use PowerShell, you can actually run some Linux commands. PowerShell enables you run some Linux commands that you cannot run when you're using the command prompt, right? So how do you access these two things? So you can come and you can click the start button and then you search command and then you see command prompt. So we have this. When you click on it, there's this black window that pops up. And then up here it's written command prompt and then say Microsoft Windows. This is version 10, Microsoft Corporation, all rights reserved and all that. And then we have this one here. So when you look at whatever is written here, we have C and then full colon. Is this the forward slash or backward slash? I don't know what this is. And then we have users and then we have load. And then we have that greater than sign, and then there's that cursor that is blinking. So it's blinking because it's expecting you to type something so that it can execute. All right. So this screen here, the black screen here, is what we call a terminal. Okay. So the terminal is the screen, the black screen, right? But now this black screen, how is it able to take whatever you typed here and then it tells the computer, the operating system that Lord typed this and then this means that he wants to do this, so you need to do this. Okay. Now within the terminal here, we have something that we call a shell. So we have a shell. So a shell acts as the middle layer between you who is using the computer and the computer hardware. Okay, as a middleware. between user and the hardware. So the shell acts as the middleware between the user and the computer hardware. Um, Now, there are different types of shells. For example, we have uh, it's read as bash, but um, actually, you know, the shell actually uh, is a middleware between the user and what we call a kernel, not just the hardware. And then now the kernel is what communicates with the computer hardware, communicates with the hardware. Okay. So when I say this guy here, this Linus Torvald built Linux kernel, basically he built a system that is able to uh, take the commands that you're typing and then it translates them so that the hardware can understand. When we talk about hardware, we're basically referring to the CPU of a computer. So the types of shell, we have bash, which this basically means born again shell. We have Z shell, um, we have the PowerShell and many others. Okay, so that is basically, in a nutshell, what happens when you type commands. Okay, now there are people who use Git Bash. We're going to talk about Git Bash in a few when we'll be talking about Git. Okay, but now, how do we navigate our computer through the CLI or through the command line interface? So we have this black screen here. Basically, for us to be able to communicate with our computer using the CLI, we need to know the commands. Okay, so I started by saying that the command prompt is the classical. I think somebody is raising a hand. Sylvia, somebody.
Uh, okay, Sylvia had asked a question. What's the difference between Bash and Git?
Oh, okay. I've just said we are going to talk about that in a few. But
Yeah.
the difference between Bash and Git, um, Git is a version control system. Bash is a shell. That's the main difference. Okay, but you're going to understand in a few. Okay, so this is the command prompt, but I don't want to use the command prompt because, honestly speaking, I'm not familiar with Windows CLI commands, but I'm familiar with the Linux commands. So that's why I prefer using the PowerShell, because PowerShell is more advanced. That is the first thing. The second thing is it enables you to also execute some Linux commands, which I believe most of the people who are learning about the CLI, you will most probably be introduced to Linux commands, right? But let's just keep this one open. Um, Let me open PowerShell. Oh my God. Okay. So, for example, the first command that I wanted to type here is this clear. So what does clear does? Basically, when I press enter, you see it clears everything that was on the screen. And now it moves up, you are on a clean screen, right? For if you are using a command prompt and you type clear, it does not work. It tells you clear is not recognized as an internal or external command, operable programs, or batch file. So why is it that when you type
Lord, I think you're
clear,
breaking.
hello, can you hear me? You- Hello.
Recording in progress.
Hello. What happened? Hello. Can you hear me?
Yes, yes.
Okay. I don't know what happened there, but you can see my screen, right? Or my oh, okay. Share.
We can see your screen, but you're breaking.
I'm breaking. What's wrong? Okay. Let me see. Hello. Now, can you hear me?
Yes, yes.
Okay. So why is it that when we type, I remember I typed clear on the PowerShell and then it worked, but then when I type clear on the command prompt, it does not work. So remember I told you guys that command prompt is the classic Windows CLI. This is we can say it's the original. It's native to Windows. So command prompt only accepts Windows commands. Clear is a Linux command. For Windows, if you want to clear the screen, you type CLS and then you press enter. Now you see when I type CLS on the command prompt, it clears. But when I type clear, it tells me that it does not recognize that command, right? Um, Another command that you can use is, okay, when you look at this one here, this is a folder. So we have PS and then C, and then we have slash users and then load. So this is a folder that contains users of this computer. So basically, when we come to the file explorer, we come to the file explorer and then we go to the C drive. So this PC, and then this is the local disk C. We press there and then we go to users. You can see load here, right? So we are inside this folder, right? And inside this folder, you can see all these. We have ice cream.ssh.vs code and all that. So on the graphical user interface here, we just click on that folder called load, and then we are able to see what's inside that folder. But on the command prompt here, for us to be able to see whatever the contents of a folder. Now, I'll be using the word directory a lot here. Directory basically means a folder, right? So inside this directory here, we can see all these files and folders. So on the command prompt or when you're using a CLI, how do you list files and directories that are within a certain directory? So in this case, we use a command called ls. ls basically means list, okay? So when you say ls and then you don't specify the folder, it will list the files and folders that are within that particular folder. So in this case, we are in this folder called load, right? So when you type ls, it will list everything that is in this folder called load. So let's press enter and wait. Now you can see everything. So the first thing we had was .ice cream screen recorder. Um, Let me put this one on the side like this. So we have .ice cream on this side. It is here as well. And then the next one we have is SSH and then .vs code also. You can see .ssh .vs code like that. We have desktop here. We have desktop here. Okay. Now, when you are on the command prompt here, when we're on the GUI here, you can see that maybe if it's a folder, you can see it's a folder. If it's a file, you can see it's a file. For example, these are files below here, like text is a file. You can see here it has indicated file. And then these ones are file folders. You can see it indicates that those are folders. But on the command prompt here, how do we know that it's a folder or it's a or if it's a file? So you look at this section here, this column where we have mode up here. So mode, and then we have like D, we have R, we have L, all these things. So D means directory. And remember, I've told you guys directory is basically a folder, right? So when you see a D, that is actually a folder. And then we also have some things here. We have like D and then R. So R basically means uh um to write. Okay. Um I don't know how to put it. You see, yes, we have like no, that is not the right word. Um okay, let's just use it. It's like you're given the rights on a particular file. So you can have a right to write that file, to just read it. Sorry, R means read. So you can have, yes, it's permissions. Yeah, permissions. That's what I was looking for. So on a file or a folder, you have permissions. You as the user. What are the permissions you have on a particular file or folder? You can have a permission to read contents of that folder, but you cannot change them. So you have write, you have read, and we have what? Um, okay, there are those other ones that I can't remember. So when you have R here, it means you can read the contents of that folder, like that, and very many other things. If it's write, then you can write. If write basically for files, okay. So if there's a file, you have the permission to write. Basically, it means you have permission to add contents to that particular file, okay. So that is that. If you want to list contents of a folder or a directory, you use ls. I don't know if ls works on the command prompt. Let's try. So you see, ls does not work on the command prompt. I think for Windows it's dir. Yes, dir. Dir means list in Windows. Okay. ls is again a Linux command. So you see, guys, why I would prefer to use PowerShell compared to Windows, compared to command prompt. But I'm not restricting everybody to use PowerShell, or I'm not telling you to strictly use PowerShell and ignore command prompt. If you're comfortable with Windows commands, then of course go for command prompt. If you're comfortable with the Linux commands, then you can go for uh, PowerShell or whichever. You can use both as well. Now, we are on this folder called load, right? What if we want to move from this folder to another folder? Let's say, okay, when we listed the folders and files in this directory, we saw there was the desktop folder or directory. What if we want to move to that particular directory? So to move to a directory, we use cd. So cd means change directory. So cd and then the name of the directory you want to go to. So in this case, desktop. And another good thing with the command prompt is, for example, I've typed desk, and then if I press tab, it auto completes, right? And then I can press enter. Now look, we were on load, but now we are on, this one was users and then load. Now it's users, then load, then desktop. So it means we have moved from load, now we are on to desktop. If we list again, you can see the contents that are in on the desktop. You can see new folder, we have Brave here, we have Visual Studio Code. So, and basically those are the things that we have on the desktop here and very many other things. Okay, so this is how to change from one directory to the other. What if you want to go back to load? You are on in desktops, but you want to move backwards here. So to move backwards, again, we use change directory, cd, but we type dot and then another dot. So this means when you say cd space dot dot, it means we want to change directory, but we want to change directory moving backwards, right? So if you press enter, you see now we are back to load. Okay. So let's just cd to desktop and then we do a few magic here. Let's say you want to create a folder. You want to create a certain folder on the desktop here. So to create a folder, we use mkdir. Okay. So mkdir basically means make directory. Okay. We are creating a directory. So mkdir, and then you provide the name of the directory. So let's say we want to, let's call it maybe movies file, movies file. Now you can see it pops up on the desktop. So we've created a folder. You see this is a folder, right? It's called movies underscore files. One thing you need to be keen on though is you see when you are creating files and folders using the CLI, you need to be careful on spacing. I know for a normal human, if you want to create a file called movies file, you will type movies space file. But you see in the command prompt, if I say mkdir and then I say movies space file, it reads this thing one by one. Okay, so the shell knows that this is a command that is stored in Windows. I'm supposed to execute it, and then it knows that when a user types this command, he needs to provide another thing. Okay, he needs to provide one other argument, and that argument should be the file name, right? So it expects one argument, but when you say movies and then file, these are two arguments you've provided. So it's not able to understand, or it's not able to know that, okay, this guy wants this file to be called movies file, right? So that's why here I used an underscore to make it one file. But if you do like this, I don't know if it's going to create two files or what. Let's see. Actually, you see, it says mkdir, a positional parameter cannot be found that accepts argument file. At line 1, character 1, mkdir movies file, blah, blah, blah. So basically what this means is that the command mkdir accepts one other argument, not two. You have provided two. You have provided movies and you've also provided file. So it's not able to understand, okay, what do you want to do with that other extra argument called file? Because I don't know what to do with it, right? So it's not able to create that folder, right? So that's that. So you can create a folder like that. You can cd into that folder, and when you cd into that folder, you can create a file. Let's say you want to create a file. You want to create a first Python file inside the movies file folder. Oh, I think I should have named it something instead of movies file, because now that I'm creating a Python file inside it, but okay. So to create files, in Windows, you use this command, new item, and then you provide the name. Let's say this is called main.py. Okay. So new item means it's basically you're creating a new file. So when I press enter, it creates a new file. Now, when I type ls inside this folder, you can see there is main.py file created. And when you click here, you can see that file is there. So it's called main. And then you can see type here a Python source file, right? So we've managed to create that file. Well, if you're on Linux or Mac OS, to create a file, you use touch. So you say touch and then main.py, maybe main2.py. I don't know if this will work here. So this one does not work. So you see, this is why I told you. So Windows PowerShell accepts some Linux commands, but not all. Okay. Touch is used to create files in macOS and I think also Linux, right? So to create a file in Windows, again, you just type new item, new dash item. Note that new N and I are capital, and then the file name. Okay. Um, to delete a file, I don't know if
Lord,
you move. Yes.
uh, th- Sylvia is saying that you're going too fast. You can slow down a bit. But Sylvia, since we are, yeah, there's also another one. I don't even understand a thing. I think you're going too fast.
Okay.
Yeah, but we can also go through the video once it is available.
Yes, 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 of course. So that is how you create files. I believe up to this point, at least, even if I'm going too fast, I believe at least people are understanding, and Sylvia is also understanding some parts, if not all. Okay, so that is how you can create files. Now, what if you want to delete a file? To delete a file, use the this command del, and then you provide the name of the file. So we want to delete main, so you type main, and then when you press enter, now if we type ls, you can see it doesn't list anything. And then when we come here, the file that we created, which was main.py, is not available. We actually saying this folder is empty. All right. Now, what if we want to? This is deleting a file. How about deleting a directory? Let's create a directory here, and then we say to delete. So we want to delete this directory. We are creating it inside the movies file. So you can see it pops up here to delete. Now, to delete a directory, um, you use this command rm and then dir. So rm means remove, and then we are removing a directory. Okay, so we provide the name of that directory to delete, and then you press enter. You can see immediately I pressed enter, that folder disappeared. All right. I think let me move this. Let me remove a lot of things on the screen so that people don't get confused. Maybe this is what might be confusing Sylvia a little bit, because there's so many screens on my screen. Then this one you can minimize it like that. Yes, let's have it like that. So that is how to we've talked about navigating directories, we've talked about listing, we've talked about creating directories and deleting them and deleting files. Um what else? What else? Let's create a new file. It was main.py. Let me clear. So we have the main.py here. What if we want to make a copy of this file? So you can say copy main.py. We want to copy it into main1.py. Yes. So basically what we did, we had this file called main.py, right? But we wanted to create a copy of the same file, but with a different name. Okay. So basically what you do is use the copy command, and then the file you want to copy. You want to copy main.py, and then you want to copy it to main1.py. So basically what this command does is it will take the contents of the main.py, and then it will transfer them to a new file. Not transfer, but copy. You know, when I say transfer, it's like it's going to leave the main.py file empty. So you basically it will take the contents of the main.py file, and then it will copy them to another file which is main1.py. So that is copy. What if we want to move a file? Let's say we want to move a file from, let's create a directory. Uh, we want to name it move file. So we have that directory there. It's called move file. So we want to move main1.py inside this folder. So normally on the graphical user interface, you just highlight this, and then you drag it and you drop it there and you're done. Here we use move. So when you type move and then you want to move main1.py, and where do you want to move it? You want to move it to move file. Okay. So you have to specify what you're moving and where you're moving it to. So I press enter, and then you can see main1.py has disappeared here. But then when you go to move file, you can see it's inside here, right? So there are very many commands that we cannot cover in one session. There are probably thousands of commands, but for starters, you need to at least be able to understand how to navigate from one folder to another, create files, delete files, move and copy files, because those are the most common things you normally do with your computer. So up to this point, if somebody brings you a computer that does not have File Explorer, does not have the graphical user interface, you should be able to at least navigate it. By the way, if you want to know where you are, for example, when I click on pictures here, I know that I'm in this folder called pictures, right? When I click on this PC, I know that I am at the root of my computer. So how do you know where you are? We use PWD. So PWD basically means print working directory. So print for me, the directory I am working on right now, or the directory I'm working in right now, okay? So when you press enter, it gives us the path. So we are on C, users, load, desktop, movies file, right? You can CD backwards, and then you can go back. I don't know if for Windows you can also go back. Let me try. Yes. So you can actually go back like that. So for example, when I type C colon and then slash, it takes me all the way back to the home directory, right? I believe this is home. The slash is home in Windows. In Linux, I think it's tilde like this. That means home. So it has taken me back to the home. You can see now I've moved all the way from desktop to load to users, and then now I'm in C. Okay. And I can actually see we have all these things. So basically, um, I am here inside this one here. So I have inetpub, logs, program files, Python module, users, Windows. You can see all of them are listed here, right? If I want to move from here all the way to movies file, what do? I just follow this path. So I can say CD, and then I want to move to users, and then load, and then desktop, and then movies file. Then I press enter, and I'm all the way into the movies file. Okay. So that's a brief introduction on CLI. Um, I think with that, we should be able now to get into version control and learn a few things, unless somebody's having a question.
Any question? Yes.
Dup. Okay, I don't know that the name, but maybe you can go ahead.
Okay, Lord. I want
Yes.
to confirm, why did you insert the backward slash in front of the file name when you are moving and copying them?
Why did I insert dot.
You have a dot and backslash.
When I was moving backwards or when I was doing what?
Yes, yes. You are putting a period and a
Oh,
and a
CD and then dot
backslash.
dot like this.
No, no, not that one. Dot
Mhm.
backslash.
Dot backslash like this.
Yes, like that. In front of the file, I think you copy or move it. So I was asking, why did you insert that in front?
Okay. What I did is, you see, uh, I think we can use this. So copy like this and then main like this.
Yes.
Uh, okay, what happens is this. You see, I told you guys, sometimes, typing might be tiresome. So what I'm doing is, of course, this is the only file that is called main in this directory. So what I'm doing is I'm typing MAI and then I'm pressing tab. So the tab autocompletes is basically able to detect that there is only one file called main and then it autocompletes the name. So the dot slash basically means this file is in this particular directory, the current directory you are on.
Okay.
Yeah. So in Linux
Okay.
systems, or
Noted.
basically in the
Thanks.
CLI, when you type dot, okay, for example, when we cd and then dot dot, it takes us one directory backwards. Okay. So what these dots mean is this. If it's one dot means the current folder you are in or the current directory. So if it's one dot, it means it's this desktop. We are currently in desktop. So that is one dot. If I add another dot, now it moves from the current to the one that is just below it. All right. Okay. Any other question? Okay. The silence means there are no more questions. So I think we can continue. So the next thing we want to look at is version control. Now,
Sorry, there's a question. Sorry,
uh-huh.
there's a question. Are you using Git bash to run the query on your command prompt?
No. I'm using PowerShell.
Okay,
Okay.
okay.
We can continue, right?
Yes, we can.
So the next thing I want us to talk about is version control. Right. Now, for you to be able to understand version control, um, think of it like this. You see, when a software is being built or when you're working on a project, big projects will not be worked on by one person. For example, when we graduate from this course, we're going to be data scientists. Now, when you're working on a project, um, you're not only going to have people who are going to analyze and whatever. We can have a team of, I don't know, we can have people who are doing analysis, we can have people who are doing querying, we can have people who are doing the software development and all that. So you see, there is this one project, but we have very many people, right? Now, if you have a project and then you have very many people, so it means there are going to be files being created here and there. People will be modifying files around and all that. But you see, before version control, there was no way to actually be able to track these files properly. And there were a lot of conflicts. For instance, I can modify a certain file. Let's say there's a file called main.py. I added a line. Let's say the line that I added was print uh, hello world. So I have added this file. I have this file. I have added this line of code. And then for some reason, um, uh, Joseph comes and adds another line. He says maybe what can he say? He adds another print and then says hello Africa, right? So I added this line, Joseph added this line. But you see the file is just one file called main.py. How do we know who added what, right? And what is the final version of the file? So there is some sort of conflict. Maybe the line I added is wrong and Joseph's line is correct. So if Joseph's line is correct and I also added this is going to create an error. And the problem is we do not know who added this line. Lord has realized the line he added causes an error. So he doesn't want to admit that I added it. So, and then Joseph also says, no, I didn't add that line. My line is this one, the one that is working. So you see, there's no way you can actually track and all that. Okay. So that's why we have version control. Okay. So version control, a definition, you can define it as you can say it's a system that allows us to track state of files. System allows us track states of file. Uh, it allows us track state of files as they change over time. Okay, as they change over time. So what this basically means is, if we have that file called main.py, the first state of this file is that it's created, it's empty. The second state can be Lord has added a line and the line reads print hello world. That's the second state. The third state will be Joseph has added a line print hello Africa, right? And so on and so forth. So version control is basically enabling us to track this. So when we have version control implemented in this case, it will tell us at first this was the state of the file, and then Lord came and then changed something, and then this was its state, and then Joseph came and changed this, and now this is its state. So it tracks the state of that file from the genesis of the or beginning up to the end until that point where now everybody will stop changing that file. Okay. Now we have different types of version control. Okay. So the first type we have local version control system. So from the name local, so local basically means changes are tracked on local computer using manual backups. Okay. Using manual backups. So this basically means you have a computer and then basically after each and every changes have been made, all those files will be brought into that computer and that's it. All right. Not so common nowadays, at least, but I believe there are some people who at least used it some time back. And then we have centralized version control system. Centralized version control system. Now, what this does is we have a single central server that stores all versions of the file. Okay. This single central server stores all versions of the file. And then the people who are working on the files now they can come make changes and then check back those files. So basically Joseph will come, make a change on a file and then transfer it back to the central server. Okay. So we have a server and then each and every person comes, takes whatever is supposed or she's supposed to work on and then return it back with the changes. Okay. I think examples of these you can Google them out. I think we have what we call Paphos. Paphos There's also Subversion, I think, Subversion, and very many others. You can check them out. And then now I think this is like the OG, is the distributed version control system. Now here, basically what happens is each developer or each personnel has a full copy of the project's repository. Okay, each person has a full copy of the repository. Okay, we're going to know what a repository or a repo is. So they have the copy of all the files within the repository. All right, and then they also have the history. Okay, entire history. So when I talk about history, basically it means from the moment the repository was created, the files that are inside, the changes that have been made and all that. So when you're getting a repository, you get a copy of it. You may be 100 or 50 or two developers, but each and every person has a copy of the repository with their entire history, right? And then now what you do is you work on this repository locally, and then you will push it back to the remote repository. Okay, so we have a remote repository somewhere, and then we have 5, 10, 20 people assigned that project. Okay, so each and every person will have a copy of this repository. They will make changes and then they will push everything back together. All right. The most common examples of this is Git, which we are going to learn. There's also I don't know if it's called Mercurial or Mercurial, I don't know. But we have Git or Git, we have Mercurial. Which other one? I think there's something called, is it Bazaar or what? Yeah, very funny names. All right. So that is that about version control. Um, Now, out of all these types of version control systems, we're going to learn just one, which is a distributed version control system, which in this case is Git. Why are we learning it? It's the most common one, and we have it's open source, and we have an amazing person called Linus Torvalds who created it, and he still contributes to it. Right? So, what is Git? Git is a distributed version control system, just like we've talked about. We've listed examples of distributed version control systems, and we've concluded that Git is an example of distributed version control systems. Now, Git is majorly popular because it's powerful. That can be one thing you can say about it. You can also attribute it to speed. It's fast, flexibility, and very many other things that you can read online about it. Now, we're going to get to the practical bit of it, but I want us to understand a little bit of theory about it first. So, first of all, Git was created by this guy called Linus Torvalds. I think it was created in 2005. You have to know that Git is different from GitHub. Okay, Git is a version control system. GitHub is like a server. Okay, it's like AWS for you, or Google Cloud, or Azure, and all those others. Right? So we have some basic Git terminologies that we need to be familiar with. The first one is I've been talking about this repository or repo. So what is a repository? Repository is basically like a storage location where project files and history are being kept. So it's basically like a folder, okay? A folder with project files and history, okay? So it's repository or repo. Another term that you will be hear a lot on Git is commit. Commit basically means to save, okay? Saving changes to a repo, okay? Repo or repo. What? Yes, we also have branch. So branch is like you can say it's like a separate copy of the project, okay? Of main project. So we can have, for example, we have the repository or repo, which is the main project, and then we can create a branch. So a branch will be basically a copy of that particular project. You can work on that branch, and then you can merge it again. Okay. So now that we've talked about branch, we need to also understand what merge is. So when we say merge, basically merge is like to integrate changes from one branch into another. Okay, from one branch into another. That is to merge. So you create a branch, you work on it, and then you merge. Okay. I think there's also clone. So clone is to make a copy of a repository to your local computer. Okay. Copy of remote repo to local computer. Okay. So that is to clone. We also have yeah, push. Because we talked about clone, we have to talk about push. Push is basically to upload committed changes. Okay, upload changes from uh, local repo to remote repo. We're going to understand what local repo. Okay, let's just talk about it. Local repo is the repository that you have on your local computer, the computer you're using. For example, I'm using my computer here. So if I create a repository here, it's a local repo. If I push this repository to a remote repository to GitHub, then it becomes a remote repo, right? So we have push. We talk about pull also, but not the pull you guys are used to. So we have pull. Basically, it means to download updates from updates from remote repo. That is to pull. What else can we add? I think that's that. Maybe there's conflict also. So conflict is basically when, let's say, two people edit the same file, and then whatever they've edited are different. So they will be what we call git conflicts. Okay. But that is it. So the way Git works is we can have like a main server or repository there, and then what happens is we're going to have different people pulling and pushing from this main server. So the first person we can have here is Joseph. Um, we can also have um, we can also have another person. Um, I'm trying to design this thing to look beautiful. We can also have another person here pulling and pushing. Maybe this one can be Velma. Uh, uh, we can also have another person also here uh, doing the pulling and pushing. Maybe we can call this person Cynthia, and very many others. So you can have as many developers as possible that you'd want to, work on the project. So these people, they pull from the remote repository, they work on their changes, and then after that they push, right? Like that, like that, like that. If there are conflicts, they resolve it, and then uh, the work continues until the project or the program is done. Now, how do we use Git? So to use Git, how much time is left? What's the time? Oh God. So to use Git, um, first of all, we have to install Git on our local computer. So to install Git for Windows, I think if you just go to your browser and then search Git download. So, okay, it's true, my internet is misbehaving. Yeah, so Git, the first link here, you just click on download, and then it will bring you here. So I understand that this is where you downloaded Git Bash for those people who have Git Bash. When you download Git Bash, it comes with Git, right? That is on Windows. For people who are using Linux and macOS, you can click on the Linux link here and then you'll be able to download for Linux or macOS. But I think Linux comes with Git already installed. So sometimes you don't need to install Git on Linux. But for Windows, the same link you use to download Git Bash, when you download Git Bash, it comes with Git already, right? So for you to be able to know if Git is installed, you just type Git and then dash dash version. You can see it will tell you the version. So this is version 2.51 for Windows, right? So it means Git is already installed in this computer. Now, when you install Git, first thing you need to do is to configure your username and email globally, right? So for those people who have GitHub accounts, you use the GitHub username and the email you use to create your GitHub account. If you don't have a GitHub account, make sure the username and the email you set up here is what you will use to create um your your GitHub account. So what this username and email does is basically it enables you to be able to initialize Git in any directory within your computer, right? So to do this, you type Git and then config and then dash dash global. So you want to configure Git globally, right? So we start with user, or you can start with email, user.name, and then here you provide your username. So my username is Lord Abiola, right? And then another one is git config dash dash global user.email. And then the user email for my GitHub account is abiolajames.protonmail.com. And then I press enter. So after doing this, you can check the logs. You can type git config, git config list like this. So when you type git config list, you will see the user.name here and then the user.email here. So I've configured this one, so I'm good to go, right? I am good to go. Okay, let me not remove that one. So now Git is installed, Git is configured on my computer. Now I want to start using Git. So what do we use Git for? We say to track changes in files. Okay. Now I want us to use this folder here, movies list. Okay, movies files. So let's go to movies files. Let's so let me remove this folder here. Um, And then let me delete this main.py. Okay, so there's nothing in this folder. All right. So I want Git to be able to start tracking changes that I'm making in this particular folder. So to do that, of course, I've created the folder. So what I'll do is I'll type git and then init. So git init means git initialize. And then I press enter. And then it says here initialized empty git repository in this particular folder. So if you look at here, we are inside the movies file, and then there's this .git folder. All right. So it's this folder here where Git is able to track changes that you make on every file within this movies directory folder. Right. So it means there's a folder inside this folder called movies file that is called .git. Dot here means it's a hidden folder. They've made it hidden so that you're not able to tamper with it or delete it by mistake. Actually, if I type ls, you can see it does not return anything. This folder is hidden. To list hidden folders, it is ls-la. Oh, this one does not work on Windows. Uh, okay. I don't know what command they use on Windows to list hidden folders. If you're on Linux, you can type ls and then -la or ls-a, I think. For Windows, I don't know. I don't know. Now, we've initialized this folder with git. If we type git and then status, so it tells us gives us some information here. So it says on branch main. So I gave an definition of branching. Basically, you create a copy of a repository. So right now we are on a branch called main. So when you initialize a folder with git, it creates an automatic branch called main. Back then it used to be called master, but then they had to change it to main because of these things to do with slavery and all that, because master is like you're referring to somebody as slave and a lot of things. So they changed it to main. And then the next thing it says no commits yet. Remember I told you commit is to like save. Okay, no commits yet. We have not saved anything yet. Nothing to commit. Create copy files and use git add blah 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 to track. Okay, so let's create a file. Let's create a new file. Let's call it main.py, right? Then press enter. So we've created that file. If we type ls, we can see main here. Now let's type git status again. Now, when you type git status again after creating the file, we are still on branch main, no commits yet, and then it says untracked file. So it means Git is telling us, you've initialized this folder with Git, but I'm seeing also you've created a file here called main.py, but you have not told Git to track it yet, right? So that's why it's telling us here untracked file. So Git will just let you know that there's a file you've created, but you have not told me to track it yet. So, and then it gives us a command. It says use git add file to include in what will be committed. All right. So for Git to start tracking this file, we need to use the command git add and then the file name. All right. Main.py. And then when you press enter, and then now let's check at git status. Now look. So it says changes to be committed. Now you see it turned from red now to green. I believe this is green. I'm stupid with colors. Okay, so changes to be committed. So it means Git has started tracking this file. Okay, basically it means by tracking, I mean every change you make in this file, Git will alert you and tell you, okay, there's a change you've made here. Let's make changes inside this file. So let me open this file in Visual Studio Code. Yes, so the file is open on Visual Studio Code. Yeah. Okay, let me add. I think that is visible enough. So this is again Visual Studio Code. Guys, you need to know that Visual Studio Code is different from um, Visual Studio. Visual Studio is an IDE. IDE is an integrated development environment. It's made for specific languages. But Visual Studio Code is a text editor, all right? And you can use it to code in every language. And then another good thing with Visual Studio Code is that you see the terminal we were using, this black screen we were using there, the window, the PowerShell. You can open it on Visual Studio Code by coming to the terminal here, then press New Terminal. And then it opens down here. You see, we are still on this part, movies file, right? You can ls, and then you can see main.py, right? So we'll be checking our git statuses on the command prompt here. So instead of having to go back to the PowerShell and all that, we'll just be doing everything here. Now, let's write print, and then we say hello Africa. We've added a line. Now let's check at git status. Okay, changes to be committed like that, and then changes not staged. So Git is now tracking this file, and then here it's telling us that this file that Git is tracking has some changes that needs to be committed. All right. Now, let's commit the changes. So git add, and then main.py, and then git commit. We want to commit the changes, and then dash m. Dash m means message. Okay. So what Git does is it uses these messages to track your files. Okay. So you need to provide a message. The message basically will help you be able to know at what stage of the file that you edited it and what did you change. So here I can say maybe add print statement, and then I press enter. Okay. Now it says we have that main root add a print statement. It records the message you provided, and then one file change, one insertion, right? And then create mode main.py. So it means this file is on create mode. And then we added something. That's why we have one insertion plus. Okay, it means we added something. Let's add another statement here. Let's say print Velma likes Python, and then press enter. We come here to git status, and then modified. You see, it says modified. This file has been modified, but these changes have not been staged yet. So we need to stage them. So we need to type git add, and then main.py. By the way, you see, every time you make changes in a file, you have to type git add the file name and then git commit like that. But you can do this in one line. You can say git add and then the file name. Then you can say and git commit like that, and then say add another print statement. Then press enter. Oh my goodness, I did not close that one. Okay, and git commit dash m add another print statement, then close it. Oh, this. Okay, I've seen what I've done. I've done something stupid. This and here is not a Windows command. So for Windows, I think we are supposed to put semicolon and then press enter. Good. So it says again one file change and then two insertions, and then there's one deletion. Okay, so we have two insertions here. So basically it means the first stage we added that line hello Africa, the second one we added Velma likes Python and all that. So you see Git is actually tracking each and every change that we make on this file. Let's type git. Is it git log or logs? Yes. So if you type git log, now let's see. This is the most current change we made. So we have a commit, and then we have head main. So it means the head of our Git is now pointing to the main branch, right? And then the author is Lord Abiola with that email, and then the date. So this thing was changed on Sunday, 19th at 6:28, blah blah blah, plus 3 GMT. And then this is the commit message. And then this is the one that we started with. Okay, so again, that is the commit. This is like a commit ID. If you'll be searching for commits, sometimes you can make a change in a file, and then later on you'd want to go back to that version of the file. So for example, we made this change, but if you want to go back to this version of the file, you can use this commit ID, right? So again, it records the author and the date and the commit message, right? Okay, I hope that is understood up to that point. Now, what if we delete a line? Let's say we delete this line. Let's delete that line, and then let's commit, and then we say delete last line, then press enter, and then let's check out git status. How? Oh, okay. So git status, okay, nothing to commit yet. But look at here. So we have one insertion, that is the insertion that, so this is the only insertion we have, and then we have two deletions. I can't remember what we deleted again, but it's recording too. I think there's something else we also deleted, but it's basically recording. You see, the funny thing with Git is even if I had this space and then I delete it, it will be able to record that, okay, there was some blank space somewhere, but Lord deleted those spaces, right? That's the good thing. Now, that is that on Git. For you to be able to, and you need to take note of these guys. Don't open your terminal and then you're on the home folder, for example, users and then load. I don't know what yours will be. For example, for Velma, it will be users and then Velma. For Joseph, it will be users and then Joseph. If you initialize this folder with Git, you'll be in a serious problem because it seems like your entire computer will be initialized with Git and Git will be tracking it. Okay, so just use Git to track that particular folder you're working on. You need to be careful on that. I think there are people who have made mistakes on that. You can see here, I'm only tracking the movies file folder. Okay, now we've seen that when we committed changes, it was talking about on branch main. So what is branching? Branching is basically creating a copy of a file, and then um, uh, you make changes on it, and then you merge, right? So if you type git branch like this, it will list all the branches that are here. So we only have one branch, which is main, and you can see it's green. It means it's the active branch, right? Let's create another branch. Remember, when you create this branch, it's going to have a copy. It's going to be a copy of the main branch. So to create a branch, you use git and then branch. Git branch, is it dash C or what? Git branch, and then what do we call this branch? Let's call it new branch. Then press enter. Now, if I type git branch, you see now we have two branches. We have main branch, and then we have new branch. Main is green or highlighted. New branch is not highlighted. It means we are right now in the main branch. Now let's go to the new branch. So to go to a new branch, you use git checkout and then the branch name, then press enter. Now look at what it says: switched to branch, new branch. Now if we type git branch, you see now new branch is highlighted green, so it means we are on this new branch. Now let's list whatever is in the new branch. You see, it's still this file, so it is a copy of of the main branch. Now I want us to do something here. Let's add a file. Let's say print, and then you say that file. We said Velma likes Python. Okay, so we are on this branch. I don't know if you can use cat here. Oh, good, we can use cat. So cat basically is a command that you use to read the contents of a file. Of course, we are seeing this one here, but uh, let me show you why I wanted to read it here. So we are on this branch here. We are on the new branch, right? The new branch, we have changed this file. We've added one line. But remember, in the main branch, we were only having this one line. So I want us to go to the main branch and see what we have. So maybe we can use this terminal here to go to the main branch. So let's use this terminal. So let's see, git branch. So we are on new branch. So let me go to the main branch. Check out main. All right. So switch to main branch. Now we've switched to main branch. We still have the main.py file. Now let's use cat. Remember, on the new branch, cat showed us this version of the file. You can see it has two lines: print hello Africa and then print Velma likes Python. Now here, let's use cat and then main.py. Okay, we are on which branch? Why is this thing disappointing me? We are on main branch. Okay, I think let's do it like here. So git checkout main. Okay, good. So you see, we moved to main branch. I think on the terminal it was not detecting because this one was still on the new branch. Now you see what's happening. We've moved to the new branch, and if we type here git branch, we can see its main. So when you come to main branch, you can see this file has only one line, which is hello Africa. But when you go to new branch, check out new branch. I did not save it. Stupid me. Okay, let's add this one. Print Velma likes Python. I don't know if Velma really likes Python, but it's okay. So we have that one. So this file has Velma likes Python. But I think we commit. Let's commit git add main git commit. Then maybe say Velma is serious. Okay, don't put this kind of commit messages for your commit on your commit messages, but I'm just using this. So we have that one. Now let's go to main branch, git checkout main. You see, main only has one file, one line, but that other branch, new branch, has two lines. Git checkout new branch. This one has two lines. All right. So it means we made a copy of the main branch, we pulled it aside, and then we made changes inside it. All right. After making changes, now we need to be able to merge it. Okay, because remember, the main branch does not have the changes that are on the new branch. So for main branch to have changes on the new branch, we need to do what we call merging. Okay. So to merge, we have to go to the branch where we want to do the merging from. So we want to merge new branch into main. So we have to move back to main branch. Okay. So let's go back to main. Let me clear so that at least things become visible. So we are back on main. Here, if we check at git status, it actually says nothing to commit because there are no changes we made on our main branch. Okay, we did not make any changes on the main branch. Now to merge, we use the git merge, right? After git merge, we provide the branch name. So we want to merge everything from new branch into the main branch and then press enter. Now you see this line of updates on the main branch. And then if you look here, it says updating. So these are the branch IDs, and then fast forward main, and then plus 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 minus. So these are the deletions and the insertions we made. For example, we had 3 insertions and then we had 1 deletion. I think this one was some lines that I deleted there. Okay, so that is how branching works in a nutshell. Okay, now let's talk about GitHub. Now, remember all these things we have done here, the creating of the initializing of this movies file with Git, uh, checking status, adding files, committing, and all those funny things we've done. We are doing them locally. Okay, we are doing them locally. How about if you want to move it remotely? Okay, because if we do it locally here, Git is only tracking these things on our local computer. If this computer gets lost, my files and the entire Git history is lost. So I need to put it on a remote repository somewhere where if my computer gets lost, I can get a new computer and then just pull those things from the remote repository and continue with my work. So that is where GitHub comes in. So let's go through let's go to GitHub. Um, so github.com. Okay, I already have an account. Okay, I already have an account. If you do not have an account, it will take you to the sign up page. You need to sign up, create an account, and do a lot of things there. Then you will have something like this. Okay, mine is in dark mode. You can put yours to light mode based on whatever you're comfortable with. So in this middle section, we have the home. So on the home here, you have like some of the projects that people are working on. You see, the people you follow and all that. So I follow these people. There's this guy here. Remember, I told you to look out on this guy, Guido Van Ross. Oh, I got this name correct. So you see, he's the Python creator. You can see every project he works on is Python. So these are the repository. You see these things here. For example, these are popular repositories of this particular man here. So we have this repository called Patma. Okay. So Patma, and then you have pattern matching and all that. I think this is for pattern matching, some ML stuff and all that. So when you click on the repository, look, so we have these sections here. We have code, we have issues, pull requests, actions, projects, security, insights, and all that. So code, basically, these are this is the section where you have your files, the repository files. Okay, and then we have issues here. So issues is basically, if let's say you're working on a project, you face some issues or bugs. Remember, this is a project that a lot of people are working on. So somebody was working on something, he or she's facing or has encountered a bug that he or she is not able to fix. What does he or she do? You can raise an issue. Okay, you create an issue so that somebody else who is able to resolve that issue will come and resolve it. And you see, this thing here, we have 92 issues, 43 closed issues are 43. So it means these ones have been resolved. So let's look at, for example, this. Please document the design decisions behind PEP 634. We learn about PEP, don't worry. And then you can see here, A good thing with the issues is people can actually chat and discuss. So you can see Guido van Rossum is chatting and commenting with other people and all that. You can look at these ones later. And then we also have what we call pull requests. Okay. So what is a pull request? Now, let's say I've let's say Joseph has a repository. Okay. I've come across Joseph's repository, or he has added me as a contributor into that repository. Now, Joseph has the main rights. I'm a contributor. So I work on a feature that is part of that repository. I'm working on some small feature of his software. And then after that, I do not merge it directly onto the main branch. Okay. It might bring some issues. So what I want to do is before Joseph merges whatever I've done with this code, he has to do some review. He has to check what I have done and all that. So what do? I create what we call a pull request. So basically a pull request is like I'm requesting Joseph to review what I have done. And if he's okay with it, he can combine it to be part of his project. So that is what we have here. So currently I do not have a copy of this repository, right? So I cannot make any pull requests. And then we also have some other ones like actions, which I don't think these ones I think for automation and all that. We have project security and all that. These ones are not so much important. Okay. So this is GitHub. Now, remember guys, we created a repository. All right. Our repository was called, oh, I've forgotten. Yeah, it was called movies file. Okay. So our repository is called movies file. So this repository is local in my PC. I want to move it to GitHub. So what do? I come to GitHub and then I create a new repository. You create repository here. So there's this button called new, or you can come up here and then click on this and then new repository, right? But I prefer here, and then you can also have a list of all the repositories that you have. Okay, so your repositories will be listed here like that, right? So that is that. So let me create a repository. So click new, and then the repository name, you give it the exact name you gave the local repository. Okay. So in a repository, and then choose visibility. Here you can decide to make it either public, means everybody can see it, or private. Okay. So private is basically only you and the people you have invited can view it. So I want to make it public. I don't want a gitignore file. We'll look about gitignore if time comes. So click on create repository, and then it's creating the repository. So it has created a repository. All right. Now that it has created a repository, how then do we move our repository from the local PC to here? They have given you steps here. They said, if you are creating a new repository on the command line, then use these commands, echo like that, and then initialize it, add a readme, commit, and then git branch -m like that. But you see, we already have a repository. Okay, so we are going with this option, push an existing repository from the command line. So the command we're supposed to use is git remote add origin, and then we have this link. All right, so we have https github.com/your username, and then the repository name, which is moviesfile.git. Okay, so let's copy this command here, and then after copying that command, let's come back here. So you can come back on the terminal or on the VS Code. Let's use this one, and then let's paste it here. So we have that, and then we press enter. So that's the first step. Okay. Now, second step is git branch main. So basically, this is just to confirm that we are on the main branch. So like that, and then the last command is git push um, git push and then -u origin main. So git push -u origin main. So this command does something. Remember, I told you push is used to move your repository from local computer to the remote repository. All right. And then we have some things here. We have dash u. Dash u here means upstream. Okay. So when you talk about upstream means Git will always remember every time you come to this folder and you want to push it to the remote repository, you can now just use git push because we've used upstream here, u. All right. And then origin basically means which branch are we pushing on? So origin is main. So we are pushing to main. So we press enter. Of course, it's gonna take some time, and then yes. So branch main setup to track origin. So you see, now it will always be tracking the main branch because we've used upstream here. Okay. Now let's come back to Git and then refresh. So when you refresh, you see there's some changes. We have movies file, which is a repository here, and then we have the file that is inside movies file, right? And then the commit message was Velma is serious, and then 12 minutes ago. So you might be asking yourself, why is it 12 minutes ago? We just pushed it. It's recording the time we committed it on the local repository. All right. So you can open this file and then you can see whatever we added here. Okay. So that is that. What if you want to pull? You want to um, you want to get some repositories from GitHub and then pull them to uh, your local repository. So, for example, uh, okay, I don't want to touch that. Let's look for some random repository that we can push. We can pull. Not that one. This is a contribution. I want to use the repository. Okay, let's see if we can pull something from this famous guy. Oh, this one has been forked already. I have forked this. So fork means to make a copy of another person's repository. So for example, we have this repository from this guy called CPython. All right. So oh, by the way, I think we can use this. So CPython, this is a Python compiler, right? So he wrote the Python compiler and all that. So you can see forked from Python, CPython, right? And then this branch is that one commits behind. So if I want to pull this branch, this particular repository to my local computer, you come and click on code here, right? So, okay, will I need that one? I don't think this is going to work because I've configured. Okay, that configuration is not going to work for me. But okay, basically what you do is you get the repositories link. Like in this case, this one is the link, so you can copy it. And then when you come to your terminal, you can go to the folder that you want the repository to sit on. So for example, I can create a folder, maybe cd, and then I call it cpython. No, not cd. I can call it cpython and then move to cpython. So I want to copy that particular repository here. So I can just say git oh no, not git clone, but git pull, and then I will provide that particular URL. So okay, this one is not going to work for me because no, not pull it, because of the way I've configured my my GitHub. because I'm using what we call tokens for purposes of security. So when you come to settings here, settings, and then developer settings, and then personal access token. So I'm using these tokens to be able to pull for purposes of security. So that is why if I'm to pull or if I'm to clone a repository, I have to explicitly provide the token that I'm using and then also the repository link. Okay, I think I've talked so much. What else do I have remaining here? Okay, anybody with any question up to that point? Any questions before I invite the next person to explain for us what to do on the code challenge? Okay, I think if there are no questions, I think allow me to invite Ebenezer to take us through the code challenge. I think Velma, you can take it over and invite Ebenezer.
Okay, thank you so much, Lord. I hope we've all understood. There was a question, how do I change my email? I think when you
Email
are working on the GitHub. Kelly, is that correct? Yes, yes. How can one change their email?
when you're configuring your GitHub for the first time or what?
Lord, are you in?
He wants to check the email when configuring GitHub with email or what?
Kelly, please expound. The email on my Git is different from my Git.
Oh, the email on Git is different from the email on GitHub. So just run git config global user.email and then provide the email you want to change to. So for example, if the GitHub email is 123@gmail.com, but the Git email is 23@gmail, so you will just run git config global user.email and then you write 123@gmail, the one you're using on Git.
Okay, thank you so much, Lord. Wow. We didn't know we'll take this. It's 2 hours in, I think. No? Yeah, yes, almost 2 hours in. So thank you so much, Lord. Let us invite Ebenezer to take us through the code challenge. Ebenezer?
Hello, Velma.
Yes, yes.
Yeah,
Hi.
yeah. Hi, good evening. I'm trying to
Good evening.
reach out Lord. Let Lord continue today. I will support him.
Okay.
I've not really been settling down this week. Let him continue. I will support him today. I will engage him after.
Lord? Lord, are you in?
Oh, sorry. I went to grab some water. Yeah, you're saying?
Okay, Ebenezer is suggesting that you can continue.
Please, Lord, continue today. I will support you. I will engage you after the class.
Okay, give me a minute, please.
Okay.
Okay. That's okay. As Lord is taking a minute, I hope we've all understood so far from what was remaining yesterday. Yes, just you can use the emojis, you can use the reactions so that I can know we are all at par. Thank you. And guys, kindly fill in the feedback form. Even as we continue through the session, you can just fill in the feedback form. Yeah, thank you so much. The recording will be shared, I think latest tomorrow. Yeah, so yes, Lord is ready. Okay.
Okay, so why isn't this thing getting lost? Okay, so for this one here, I think let me just provide an explanation on what's supposed to be done because I don't think they're supposed to give out direct answers. In this graded code challenge, you'll apply our Python programming skills to automate more complex movements of our farm equipments. We'll use functions to make our code more modular, making it simpler to read, modify, and extend. Download the additional files and extract the zip file into a folder. Oh, okay, so the zip file contains assets folder, which are files we need to run the simulation. We also have code challenge, loop logic, functions, notebook. So we have the notebook. This file is a workbook to complete the code challenge in. So you need to so this notebook is the file you will have to zip and submit. Oh, okay. So this one contains whatever you're supposed to do, but this is what you're supposed to submit. GCC submit loop and functions dot ipynb. This is what you need to you need to submit. So I think you need to do your work here, and then you will transfer your answers here, and then you submit. Complete the code challenge in the code challenge loop logic functions notebook, but do not submit this workbook. So you're not supposed to submit this, right? Transfer your answers to GCC submit loop and then submit this file zipped as your answer, right? So I hope up to that point you've understood the instructions. There's a zip file that contains assets folder, the code challenge notebook, and then you need to work on this notebook. But whatever you'll be submitting is the GCC submit loop and functions. Okay, so start test. Oh God, so why is it logging me out? Yeah, so Download questions, upload answers. So I think you're supposed to download this. So it's here, the code challenge notebook, which is basically for loops and functions. So in this code challenge, you apply Python programming skills to automate more complex movement of our farm equipment. We will use functions to make our code more modular, making it simpler to read, modify, and extend. This notebook should not be used to work through the code challenge, but should be used to work through the code challenge, but should not be submitted. You have to transfer your answer to that one. I think that one they have mentioned several times. Our goal is to develop fully autonomous farming equipment. These machines will not just follow preset functions. They will make intelligent decisions based on real-time data. Imagine tractors that know when to plow, seeders that understand the best planting patterns, and irrigation systems that water crops precisely when needed. I have to read this because I have not gone through this thing, guys. Every grand plan starts with the first steps. For us, it's creating a digital mirror of Majindogo farming ecosystem, a comprehensive digital twin. This virtual model will be testing ground, blah, blah, blah. Oh, somebody is raising a hand.
Yes, Lord. I want to,
Yes.
so that others will also learn. I noticed that when you download that thing, there is a student pack. You have a file code challenge loops logic function inside the logic pack. Is it that they are telling us that when you finish, you copy it and use and rename it to GCC submit loops and function? Are they asking us to rename the file you worked on? Is that the understanding you are having?
Okay, I think we have these download questions, and then we have upload. Okay.
Yes,
So here it is. So you see, when I
yes,
click on download question, it has all these things. We have assets, we have code challenge, and then we have the GCC. So you're not
yes,
renaming it. Yeah, you're not renaming it. When you download it, it comes with
yes.
all the three, a folder and then the two files. So you'll do your work here, but then you'll transfer your answers to this one. And then this is what you will submit after zipping it.
No, hold on. When you work the first one on top, when you do your work there, I used to copy the content and put in the lower one the GC submit. Is that the logic?
Okay, what they have said in the instruction says copy your answers from this to this. So I think it will be okay to just follow whatever they have mentioned there. So basically, instead of copying the entire thing, you might copy what they don't want. At least I don't know how they have structured this. I don't normally open this on this Windows computer, so I don't have notebook installed on this Windows computer. I normally use another computer, so that's why I'm not able to actually open it. But I think the
I
best way
always
should be
okay.
the best way I think would be to just copy the answers from this file and then paste them here.
They basically contain the same thing when you open it on notebook.
Ah, that's nice
Both
then.
files
So
basically both contains the same thing, but the interpretation I'm having is when you are through with all you are doing here, you rename it, except if others has gone through and have a different idea they can share. Rename it to this new one.
okay, I think if that one can work, well and good. If I think if they have if everything is the same, then you can work on this, make a copy of it, and then rename to this. It's always important to at least have a copy remaining online somewhere.
Yeah.
Okay, so initializing simulation code. So in order for the simulation to run, we have to install Pygame package. This Python package is used to draw graphics for games written in Python. and we'll use it to see the results of our code. First, we install Pygame package with that one. So you need to install Pygame. Pygame is just a Python package that is used by game developers for creating the graphical interface of games and all those other things. So it's basically used in game development. Then run some code to set up the visual. Before scrolling down, remember that we don't have to understand every line of code in the cell below. Import Pygame, import logging, import random. So Pygame is for gaming, logging is for errors and also logging. Random just gives us random numbers or whatever. But they've said you don't have to understand the code. But I think this code basically, because they're talking about farms and tractors moving, so it's going to be like a game simulator where you can have like a farm. It can be maybe a square or rectangle, and then you have tractors moving around that farm. So you'll have objects that are in the shapes of tractors moving. So that is basically what this file does. Okay, because I think we have assets folder. So in the assets folder, you might be having maybe pictures of things that look like tractors that are supposed to move around the farm. And then when they move, you simulate basically plowing and all that. So that's that. Oh, this code is long. Okay, so that's the end of it. Pygame.quit. So that closes it.
Hello, Lord. Hello, Lord.
Yes.
Hello. Can you scroll in that code up where they have some variable defined? Can you scroll up where they said define tile names? It's up. Scroll up. Up. Scroll up again and look at where they define function generate field. Look for function generate field.
This one.
In the code, can you scroll down? No, the code itself.
But this is the code for
Hold
this
on.
function.
Here.
You want me to scroll
Yeah,
going
look
up and
at
down?
no. Look at these defined tile names for borders, corners. Look at the name. It seems bottom right is like the interchange, or am I reading wrongly? From
What do you
this
mean it has
variable
been
itself.
interchanged?
Look at the variable names. Look at the variable names. Grass corner. TL looks like top left. Grass corner TL looks like top right. If we look at the variable name compared to the content of the value itself. Am I interpreting wrongly? Look at BL,
Oh,
look
so you're
like
saying, for
bottom
instance,
left.
grass corner TL is top left, but then this one is soil bottom right.
So I said, am I reading wrongly, or can you both share
Maybe
ideas
because
on that?
for grass, that's one in range with, for that in range height. Field is a 2D array filled with grass.
They are setting coordinate on the field.
But this is grass, and then you can see whatever is inside here is soil. I think I'll need to run this thing and see what it does.
I just opened it this evening and I was looking at it and it looks doesn't align.
You can also use ChatGPT to you can copy this function and then you paste it on GPT and then you ask it to explain. I think that can also be good. It will be able to explain. But I'll need to run it and see. Generate fields or height width generates the complete layout of the field with specified height and width. It includes an additional outer layer for grass border and corners and fills the interior with random soil variation. Okay, so it generates a field, and then of course the field has additional outer layer for grass. So we have grass border around the field, and then the
Yeah.
corners have soil variations. So this one define the tile names for borders, corners, and soil variation.
Corners and soil variations.
Soil variations, soil 1, soil 2, and then we have soil 3. Okay, I'll have to run this one and understand it. But they've said you don't need to understand everything. I also don't understand everything here. But
Yes, but you need to have a little graphs.
I'll have to run it though and see what it does. If we get any errors after running the cell above, we have to make sure we have installed Pygame and extracted all of the files in the asset folder. Next up are some parameters we can
Anna
set.
Eyasi, our Lord, Anna Eyazim is telling us it's mislabeled. Can you shed light on that, Anas? Anas, can you talk to us? Can you talk to us? Somebody says it should be top left, not bottom left. And we are not permitted to change anything on it. So what's our deal?
For people who have run it, is it running well on the side or what? You see, if
I'm not.
it's not providing what it's supposed to provide,
Leader,
then
can you
there might be a
allow
problem.
others? Can you hear me?
No. Come again.
Someone should allow him to speak. I can't do that from my hand.
Okay, shall I speak? Okay, let me look for Anna's. Anna, what's your, okay, I'm coming. Anna. Where is Anna's name? Okay. Anna, you can talk now. Anna, unmute yourself. Anna, unmute. Anna, can you hear me? Unmute yourself.
He has no mic.
Lord, you can continue.
Oh, okay.
Okay, he's saying, I just noticed that the labels are not representing the good value.
Okay. Okay, Hannah says no mic. I just noticed that the labels are not representing the good values, but did not run it yet.
Okay. But I think as long as it's running well and there are no errors, then it should be good to go. Maybe you can assume the variable naming there was not okay, but I'll run it and see, and then I'll give you guys feedback. I'll run it after the session.
Maybe what I would suggest is probably we squeeze out about 1 hour tomorrow to meet while we work on it tonight, and whatever challenges we have, since we cannot solve the problem together, but we can share ideas that will guide all of us to go and work tomorrow evening. What about that?
Okay. I don't know what people will suggest. But if that's what they'll suggest, it's okay.
Maybe say around 9 o'clock tomorrow, we can just come together and review challenges we have and give ideas on what to do. Since we are just about 57, or we are less than 60 in this class, we can quickly converge 9 p.m. tomorrow, have clear ideas, and everybody goes well. Because beyond class, we need to understand what Python is, we need to understand what LS is teaching us clearly.
Yeah, true. I can see somebody's hand is also up.
Lord, over to you. That's my opinion.
Yeah, it's okay. I'm saying somebody's hand is up. Kelly, I think Kelly, you can talk.
Kelly.
Lord, can you hear me?
Yes. Yeah, I can hear.
Please, I'm finding it difficult to import my asset file to the notebook. I don't know if you can help me do that, please. I don't know how to do that. I've looked for a way, but I don't know how to do it.
Okay. Okay, for me to be able to run this thing, I'll have to change computers, and that might probably take some time. But okay, where this notebook is, for example, if your notebook is on your desktop, that is where you should also have your files. Or those, yeah, that's where you're supposed to also have your files. If you have your
And
files in a different location, then it will not be able to detect them.
okay, that means I'm supposed to create a folder and then include all of them there in that folder. That note in the notebook. I'm supposed to create a folder in the notebook and then include all of them there.
Okay, what happens when you click download question? Is it a folder that you're downloading? It's a zipped folder, right?
Yes.
So if it's a zipped folder, okay, let's see. Is it a folder?
When you download it, it's going to download student pack. Student pack. So when
It
you
downloads a
unzip
student
a
pack.
zip file, when you unzip it, you will now have inside it, you have that code challenge loop function, GCC submit loops function, and assets. That's what you're going to. And for you to work, you will copy that on zip file. That your student pack, copy it as a folder. Lord, just to clarify what Kelly is asking for, Kelly is supposed to have a folder in your directory where your code will sit in. Can I share my screen so that I can demonstrate
Please.
what?
Yes, please do, please.
Yeah.
Okay, let me share my screen so that you see what I'm talking about. Can you see my screen?
I think yes, I can.
Okay. Now, this is my coming. This is my Jupyter notebook. Okay. Now, for me to have my file explorer or my file directory, if it's when you install your Jupyter notebook, it goes to Windows, it installs it in your profile, whatever profile. Mine is this, that may be. Now inside this, my profile folder, that is what your Jupyter notebook has access to. So I created a folder code here. Do you follow what I'm explaining?
Yes.
When you come to your Windows, in those of us that use Microsoft Windows, when you come to Windows, your Windows, in the directory, you have your profile, program data, you have a user folder where your profile is. Inside this profile, that is where your Jupyter notebook, that's where Anaconda install your Jupyter notes. So open that user, then go to your profile folder that by your name, open it. For you to run successfully, whatever you are seeing under your Jupyter notes, these are what comes on your profile. All these folder you are looking at on my screen come from that my profile folder. Anaconda, project, code, contacts. I went there to create a custom folder so that I can manage my code together, so that I won't scatter it within the place. So I create a folder code. That's all you have here.
Okay.
So I created the folder code. Now, for me to run all the project we've been doing, look at all the things that we've been practicing, all our code, conditional statement, conditional execution, all that we'll be doing now. Each time I downloaded, I'll come and put it in this folder. So the one we want to currently do, what I have just done is to copy the student pack and after unzip it and put it in this folder, right? So that by the time I wanted to now work on it on my, I'll come to my code and see the student pack, open it. So a moment, I've opened a lot of them. So code challenge, this is the code challenge they want us to work on. So you open it. So it brings up all those explanations. So when you finish, this was what I was, when you finish all those things that we are looking at there are these. So when you finish all your running, then you click on save here. You can close it and go back here. This is what I was explaining to Lord the other time. That is the same thing. Okay, this one is giving us the result. Okay, maybe, okay. Lord, I think this is what you are saying. Probably you copy your answer here. Maybe that's what we are going to do. But in the meantime, this is the folder, Kelly.
Okay.
This is my student pack. This.
Okay.
Then we can continue all that things and we'll share idea later.
Okay, so can I ask a question?
Please go ahead.
This challenge, does it work only on Jupyter? Won't it work on like VS Code, Python, and Google Colab? Won't it work on
It
those?
should work on Google Colab, but when you are saying Python, let me get you right. What do you mean by Python? Whatever we are doing is about Python. Jupyter Notebook is an ID, is a development environment where you run your code. That's what it's all about. Or is that, let me understand your question.
What I'm asking is, this code, would it run on Google Colab?
Yeah, it should be able to run on Google Colab because
Because I found out that it's hard for you to like upload the asset file to Google Colab. I tried, but it's not working.
if you follow what I just explained, then look at if you even your Google Colabs will allow you to see a folder you created in your the bottom line of Anaconda and Google Colab is they relate with your your profile folder. If you follow my explanation here, they relate with your profile folder on Windows. Okay? All you simply need to do is to go to your profile folder and create a code folder there or whatever you want to call it. Either you want to call it Python. I can still rename this one Python, whatever. Create a folder for yourself that you a name that you understand, and now put that your student pack inside this. Your student pack has all your assets that you are talking about there.
Okay.
Yeah.
Thank you.
You are welcome, Kelly. You are welcome. Lord, let me stop sharing. Over to you.
I think, Kelly, the problem with you not being able to figure out about the assets folder is because your files are separated. Just put, even if you are using Google Colab, make sure all the documents are in like one folder. So you see, Google Colab, you can actually connect it to your Google Drive. So you can put the files in one folder, and then you transfer them to Google Drive, and then you open them. You open the folder from Google Colab, so they will all be in just one folder. I think that will be able to help you.
Okay, thank you.
I'm also seeing a hand from, this is Sylvia.
Hello, good evening.
Good evening.
Okay, thank you. Lord, please, I want to ask 3 questions. So I've already asked 2, and it's remaining 1. The first one is that I know that when you delete files, it does not delete permanently. Like when you are using Windows, it doesn't go permanently or remove permanently. So I want to know if you are using a command prompt, is there a way it can remove permanently from your system, or it's just the same thing that it overwrites? That is number 1. Number 2 is that I forgot my password for Git and Bash. How do I change it? Because we'll be using Git now. So how will I change the password? Is there this thing that Windows does that you will just do forget password and you can be able to change it? So I want to know if I can change it and gain my this thing back. Another one is that I know that like when the guy that spoke last, someone asked what about Python, if you can run the code on Python, and the guy was saying what does she mean by Python and all that. I know that there is Python app. I think the latest one is 3.13. That's the latest one now. I know that I've used it for some time ago. I think the code can be run on Python. It's just that Python is much complicated than all this Jupyter Notebook and Google Colab and this Visual Code. So I think that's why we normally use Jupyter Notebook, the one that is user friendly. It's not like it's written with Python language, but there is still Python app that you can still run the code. So please, can you help me answer my questions? Thank you.
So the first question you're asking, if you use command line and you delete something, does it go permanently? Compared to graphical user interface where you delete something and then it does not go permanently, it still moves to the trash. So I think there are some things we deleted. But okay, basically, in short, when you delete things via the command prompt, they get deleted permanently. They get deleted permanently. It does not move them to the. It does not move them to trash and all that. And I think we can test with that. We can let's just confirm and see, because I might be talking and maybe Windows is a bit different. But so if we create a file, I think, so we have this file, and then if we delete it, normally it was created in this folder and then it was deleted. So in this folder, let me create another file. Oh, so we have this. So we had main 2.py and then we have main 4.py. So this one I'll just delete it via the graphical user interface. The other one I deleted through the terminal. So when you come to this one here, you can see we have main 4 in the trash folder, but main 2 is not there. All right. So that is why I started by saying command line is more powerful compared to GUI. When you delete a folder via the command prompt, it goes permanently. It does not move to the trash folder and then it does all those stupid things. The second question you are asking about, you said you forgot your, okay, you said Git, but for Git there's no password for Git unless you are referring to GitHub. If it's GitHub that you forgot your password, then you can just reset the password. You can just go to GitHub and then you go to, there's the forgot password link there. You can just click it and then you'll be able to reset your password.
So
The last question.
are you saying that Bash and Git, that you don't use password? Because that time I know that if I open it, it used to show me my email address. So I want
Bash.
to know. And Git. So they don't have password, because that time if I open it, I used to write my email address.
Okay, how did you open Bash, for example?
If I open my system that time, I go to search and I search Bash. It will show me that Git icon. I'll just click on it, the Bash. It comes out with my email address as of that time. But now I don't know how the thing look like, because I cleaned my laptop some times ago, so I've not been able to store it back.
So you're not able to show us now because I wanted to see what you're talking about.
No, I don't have it now. I cleaned my laptop some times ago.
Because to my understanding, Bash, okay. Oh God. Bash and password, I don't think they get along unless I'm mistaken or I don't understand what you are trying to talk about. And also when you refer, okay, remember I said there is Git and then there is GitHub. So for Git, Git is a system that you install on your computer. It does not require password or whatever. The only thing you need to do is to, once you've installed it, you configure your username and email. It does not ask for password and all that, unless you are referring to GitHub.
Okay, thank you. I'll try to install it again. If there's any issue, I'll reach out to you. Thank you.
Yeah. Please, if you get your computer and then you face the same problem, just reach out to me. You can show me, and then I can see what you're talking about.
All
Um,
right.
your last question was about you said something about Python and Jupyter Notebook and somebody telling you about not running. Okay, can you go repeat it again, please?
So I was saying that that the lady that asked question last was asking of Python, how to run the code. Can you use Python? Can you use Jupyter Notebook, Google Colab, and Studio and all that? And the guy said what she meant by Python, that that Jupyter Notebook is Python. So I wanted to say that Python also has an app that you can actually run your codes. That is just that it's much complicated compared to Jupyter Notebook and others. That Jupyter Notebook is user friendly compared to Python app itself. So I
Okay,
wanted
what's
to
the
know
name of
that
the app?
the Python app is Python and is Python 3.13. The one on my system is Python 3.13. That
Mm-hmm.
is the app. That you can
Mm-hmm.
also use it to run codes. It's just that it's much more complicated compared to other ones.
Okay, so you know what's happened, Sylvia? Okay, you are referring to it as an app, uh, the Python 3.5. Actually, the latest version I think is Python 4, 3.14, I think. So the thing is, when you download Python on your system, you see the latest version is 3.14. Then there's 3.15, which is a pre-release. So basically, it means it's still on testing. It's not stable. When you download, for example, in your case, you're talking about Python 3.13. You're not downloading an app. There is what we call a compiler and all those many other things. So basically, that is what you are downloading and installing on your computer. So the interpreter you're downloading, basically what it does is it's able to detect Python files and interpret and execute them and give you an output. So when you install it, um, I don't think it's so hard to configure. You just install it, and then once it's installed on your computer, you can actually run Python codes on VS Code. Or you can, for example, the files that I was creating here, main.py, if they have contents, I can just, okay, let's do this. If I open VS Code here, uh, yeah, this file is still here. So for example, I have Python installed in this computer, right? If I type Python and then dash dash version, Okay, I don't think is it. Let me try this. So Python is not, I don't think it's installed in this one. Okay, I think it's the other one. But basically, if you install Python on your computer and you type Python dash version, it should be able to tell you the version of Python you have on your computer. And then if you want to, for example, you have this code here, you want to execute it because it's a Python code, you just type Python and then you type main.py. So when you type main.py, this is supposed to print hello Africa on the console. So it will print here hello Africa, right? In the case of the previous person who asked about running code on Jupyter Notebook and all that. So, okay, if those things are confusing you, another thing you can do is you can install Python on your local computer. You download the files, you create a folder for them on your local computer, and then you can always run them here. VS Code has extensions. When you come on this side where you have file search, we have Git, we have all this, you come to extensions here. You can download Jupyter Notebook extension. So I think, what is its name? Is it Jupyter Notebook or what? Yes, so this one from Microsoft, I think this is okay. So you can install this extension. So it will basically allow you to be able to open notebook files on VS Code. So once you have this extension installed, you'll be able to actually open those notebooks on VS Code, write your code, execute them here, and all that. Another thing you can do is if you feel this is a long process, you can copy the sections of codes that you have on the Jupyter notebooks and then create files on VS Code, paste them, and then execute them like that. But I think that one is a bit more complicated. I hope that one answers your question, Sylvia. I'm
Yes,
also
sir.
seeing
Yes. Thank you so much. Thank you.
okay. Okay. I'm also seeing a hand from
Hello, Lord. Let me just add this. Lord, Ebenezer, let me add this to what the last question is saying. For posterity of learning, what when can you hear me, Lord?
I think I lost
Hello,
you,
Lord, can you hear me?
but yes, now you are yes, now I can hear you.
Oh, okay. I just want to give a guide. When it comes to posterity of passing knowledge to participants, the best thing is you start from the easy track. As you are progressing, you are growing. Those one you feel complicated, it's not complicated, it's based on your knowledge and understanding. But when you are growing a student into understanding, especially to coding environment, the best thing to do, and that is what ALS does. When you are rounding up your data analytics, if you recall, they were giving you the background of how you can install Anaconda, Jupyter Notebooks, Google Colabs that you can use it to manage your code. They don't want you to come with the barrage of so much setup that can discourage you from learning. They want you to concentrate on understand the in-depth of Python itself. So what I will encourage every participant on this group to do is install your Python. When you do that, install your Anaconda. When you install your Anaconda, create an environment where you will install your Alchemy and SQLite. Those are the two packages that are important. When you do that, then launch your Google Colabs, launch your Jupyter note from that place. That will make it easier for you to learn and run your code. As you are progressing and another ideas are coming, you add all other knowledge to it. And if you are unable to install your Anaconda, you can go to Google Colabs, which is online. The difference between your Anaconda with Jupyter Notes with your Google Colabs is Google Colabs is virtual, it's online. And any code you write is going to save it in the cloud for you. And you can have access to it anywhere, irrespective of your system. That's just the major beauty of Google Colabs. But when you install your Anaconda with your Jupyter Notes and Jupyter Lab on your system, if you are not on your system, you can't have access to run your code. Anyone that is convenient for you in these two. But remember, I was explaining something to Kelly the other time. Whatever you are doing is running on your profile. So when you are looking for your files, it's always in your profile. And to make to organize on your profile and be putting your code there. Those are the little varieties. Even when you are using Google Colab, which is in the cloud, it's also reference your profile. So these are the things that you can pay attention to. While you are progressing all the complicated ones, you will pick and understand. Thanks. Lord, you can go on.
Okay, I think we can take the last question from this person called Afiz, and then probably we can agree on whether to continue tomorrow about the code challenge or whatever it is. So Afiz, you can go on.
Thank you. I think my opinion about our challenge is, with the understanding we have tonight, let's all go through it. Definitely there will be one or two challenges that will crop up. Note it. When we come tomorrow, is going to be maybe 9 p.m. If you all agree, 9 p.m. what time? If you all agree, we come together. We just share it, or we can post it on our WhatsApp group, the challenge we have, and we'll probably post an answer to it. That's my opinion about it. But before I drop, so that I don't call your attention again, Lord, under our instructions, this thing has been repeating itself. I would love you to shed light on it. Use of Stack Overflow, Google, and other online tools. What tool is Stack Overflow? How do you use it? What Google are they talking about? Is under the directive of our code challenge. It's been repeating itself. I say I need to understand what they are talking about there. Can you shed more light on that?
More light on. I heard you mention Stack Overflow, Google, and all that. So what are you
Yes,
asking?
when they were giving instruction, they were telling us, if I go under the say, do not add or remove cells in this notebook, don't let me go. Answer the question according to the specification. They now move down. The use of Stack Overflow, Google, and other online tools is permitted. So I'm trying to understand what is Stack Overflow and Google, what's it talking about?
Okay.
Are they saying we can come again?
So that basically means you can Google, for example, if you don't understand something, you can Google it out, or you can search it on Stack Overflow. Stack Overflow is a
Okay.
website where we have developers who basically, if you have any issue, you can post it on Stack Overflow and then people can answer. So Stack Overflow is like this one for Alex, what is it called?
Oh,
Where you can ask questions. But now this one is for developers. So when you go and search for Stack Overflow, you can create an account. And then once you have an
okay.
account, you can ask your question. You see here, ask a question. And then other
Okay.
people who have at least understanding of it may be able to answer. Sometimes whatever you
Okay.
are asking had already been asked by somebody. So you can also
Okay.
just search it out. If it had already been answered by somebody, of course you will get the answer there.
Okay. That's good.
Yeah. So I think
Okay.
Hafiz can
Thank
talk.
you. Yeah. That'll be all for me.
Okay, thank you, Dap. Hafiz, I think it's your turn. You can talk, please.
Okay, good evening, everybody. Thank you so much for the privilege. So I think I've been having major challenge with this particular week code challenge. I think a lot of people have asked questions. They've asked like most and like likely questions that I wanted to ask. But I'm just still so confused about this whole student pack that we have to work on. Basically, in the student pack, we have three different packages. We have another folder inside it, which is the assets. So I don't know how do we like tend to run code importing the asset into maybe our Jupyter notebook, Google Colab basically. And how do we want to like transfer our answer, like copy our answer from the original file that they asked us to work on and paste it in the other one? I understand that we are already asked to convert within by um, 9 p.m. tomorrow. So what my own concern is if we'll be converting by 9 p.m. tomorrow, we might not have the luxury of time to meet up with like the sort of deadline to make 100% as ALX actually do. So I don't know how we want to like tackle this particular challenge basically. I feel or personally I felt we could have actually done this today. So probably tonight and tomorrow or before evening time, everybody could have tried to like get a hold on all these challenges that we're all facing. So basically, I feel this week code challenge that I'm going to submit just came with a lot of instructions that are is it contradicting or confusing basically? That's my question.
Okay, so the reason why um uh Ebenezer is thought it wise maybe if we can do it tomorrow is because um okay, he was supposed to go through it, but he had not had the time to actually go through it so that he can come and explain. I've also not gone through it to be honest. So the reason why he asked if he can do it tomorrow is so that he can go through it, get to at least understand some things. And then tomorrow maybe he can come and explain it in a way that people can understand because it seems a lot of people are having challenges with it. So if you can give him time to understand it, go through it, and then so tomorrow uh, at whatever time that will be decided, we can all come together and see, go through it. At least he'll be able to have understanding and also answer your questions better. You see, for now, both of us are struggling to understand what it wants, but I think uh, the basic part of it of downloading and unpacking and transferring it to where he has actually explained it very well. So what um, was also confusing people was about this part where we have these things. But to be honest, I think I'll also need to run this on my computer and see what it gives, and also from that because okay, I understand this code here, the one that has been provided here, is supposed to act as a simulator. It's like a game. So basically, it draws these things. It draws a farm, which is surrounding of grass like this. So the tractor is supposed to move within the farm and plow it, right? Now the tractor in the assets folder, I think I downloaded it or something. Where did I put it? Um, okay, so look at these. These are the things that are in the assets folder. So for example, we have blue tractor, we have free, we have green tractor, and then we have soil prep and all that. So I think these soil tiles are supposed to be, these are the tiles that are supposed to be to represent the soil, and then these are the tractors. So what Pygame does is, remember, it's like they're building a game where this tractor is supposed to plow. So if it's a purple tractor, it's supposed to move to the farm and plowing. So we assume when it's moving, going this way, for example, from left to right, it's actually plowing, all right? And then it comes back, maybe move again from right to left. So it's actually plowing like that, like that. That is what this thing is supposed to do. So that means this particular file, for it to run successfully, it has to be connected to the assets folder. It means, I'm trying to find where he's calling those images and setting them, and I can't find it. So for example, like here we have tile name. Tile name is equal to get tile by name. Tile size, no, there is no image there. But basically that is it. So it's basically, it's like you're creating a game, and of course, even in the normal game development industry, those games you play, the people, or when you're playing FIFA, the Cristiano Ronaldo you see, it's actually a 3D design of a human being. And that human being, after being designed using maybe Blender or something, you write functions that makes it be able to move, run, kick the ball, and all that. That is basically what they are trying to do here. So you create like a track, you have an image of a tractor, and you want to make it simulate the behaviors of a tractor. So a tractor can move, a tractor can go back, and all those other things. I think that answers your question. Um, I don't know what guys think about what Ebenezer suggested, maybe, but I think Velma, you can take over now.
No problem. I think we just have to wait till tomorrow. Thank you so much.
Afeez, I've not heard you. Okay, guys. How many are suggesting for tomorrow? Just type in the chat. 9 p.m. West African time will be 11 p.m. East African time. Kindly type in the chat, please.